Namaste dear students, I am B.G.Shinde sir and we are discussing chapter number 1 units and measurements of 11th physics. Up to lecture number 8 we have discussed dimensions, how to find dimensions of various physical quantities. We have seen uses of dimensions and their examples. In lecture number 9, we see limitations of the dimensional analysis and errors in measurement. So, listen this lecture up to 8. Also share this lecture to your friends. Subscribe YouTube channel so that you will get the new videos automatically in your channel. तर आज आपण सुरुवात करू लेक्चर नंबर 9 लिमिटेशन्स ऑफ डायमेन्शनल एनालिसिस. Now first limitation of dimensional analysis is that the dimensionless constant cannot be determined or cannot be obtained by using dimensional analysis. Means suppose we take example t equal to constant k under root L upon G. We have seen this example in second use of the dimensional analysis, in which we have determined this formula by using dimensional analysis, where this k is a constant of proportionality and this constant of proportionality is dimensionless. It have no dimensions, and this constant is not determined by using dimensional analysis. It is determined using experiments. So using experiment, this constant is determined. Then second is, if some expression, some formula contain trigonometric function. Trigonometric function is sine theta, cos theta, tan theta, or if some expression, some formula contain logarithmic function, means log of some number, or some expression contain exponential function, e raised to y, e raised to x, or e raised to t, then that expression or that formula cannot be obtained by using dimensional analysis. So this is limitation. Then third limitation is it is not this dimension analysis is not useful if the constant of proportionality is not dimensionless. Means if constant of proportionality has some dimensions, then dimensional analysis is not useful in that case. Means, for example, we take example F is equal to G m1 m2 upon r square. This is gravitational force, where this G is a universal gravitational constant, and this G has dimensions, and this such equation cannot be obtained by using dimensional analysis. You can verify this equation using dimensions, but you cannot obtain this equation by using dimensional analysis. So this is one of the limitations of the dimensional analysis. Then fourth limitation is, if some equation contain more than one terms, then the presence of that additional term cannot be detected, or the presence of the term which is more than one cannot be cannot be known, or we cannot know the presence of that term by using dimensional analysis. Example is S is equal to ut plus 1/2 at square. This is one equation which is a second equation of motion, You can verify this equation by dimensional analysis, but if you try to obtain this equation using dimensions, then you will get s is equal to 1 half at square. But additional term cannot be detected, or additional term cannot be found by using this dimensional analysis. So these are four limitations of the dimensional analysis. Even there are limitations, we are using dimensional analysis and dimensions in 11th standard and 12th standard in every chapter. So it is very important point, dimensions. Now we see what are the errors in measurement. Now in physics, we come across various measurements during the experiment, during the practicals. We come across various measurements. म्हणजे फिजिक्सच्या लॅबोरेटरीमध्ये आपल्याला वेगवेगळे एक्सपेरिमेंट करावे लागतात आणि ते एक्सपेरिमेंट करताना आपण वेरियस फिजिकल क्वांटिटीज हे मेजर करतो. लेंथ मेजर करतो, टाइम मेजर करतो, टेम्परेचर. So we measure various physical quantities. We measure electric current in laboratory, and while taking the measurements, there may be faults in the measurement, and those faults in the measurements which we cannot avoid but they can be minimized are called the errors. They are called the errors. Now these errors can be minimized but they cannot be avoided. So this is error. Now these errors are classified into two types. First type is a systematic error and second type is a random error. Now what is systematic error? If there is inaccuracy in the observation, if there is inaccuracy in the measurement process, or if there is a error, there is a faulty instrument used for the measurement, or person don't know how to take the reading, he don't know the procedure, or if the experiment, if the setting of the instrument is wrong, then the error which will be caused is a systematic error. म्हणजे समजा आपण ऑब्झर्वेशन घेताना किंवा मेजरमेंटची जी प्रोसेस आहे त्या प्रोसेसमध्ये काही हे जे आहे मेथड ती चुकीची वापरली, किंवा मग आपण केअरलेसनेस केला रिडिंग घेताना, किंवा मग जो पर्सन आहे त्याने रिडिंग घेताना काही म्हणजे फॉल्ट्स केले, किंवा पर्सनने जे इन्स्ट्रुमेंट वापरलेलं असेल, इन्स्ट्रुमेंट जे असेल इन्स्ट्रुमेंटमध्येच फॉल्ट असेल किंवा एरर असेल, तर अशा सर्व ज्या एरर असतात त्यांना सिस्टमॅटिक एरर म्हणतात. दॅट इज कॉल्ड एज सिस्टमॅटिक एरर्स. सो दिस सिस्टमॅटिक एरर्स आर अगेन ऑफ द थ्री टाइप्स. मीन्स इफ देर इज एरर caused due to the defective calibration of the instrument, that error is called the instrumental error. For example, in laboratory we use weight pan. It is used to measure the weight, and before measuring the weight of the object or weight of the body, we make sure that this balance shows 0 gram, and if it is not 0 gram, means if it is 0.05 gram plus, or if it is minus 0.05 gram, then this it will cause the error in the measurement, and that error is called the instrumental error. This instrumental error can be positive or negative. It may be positive or negative. So by proper calibration, you can minimize this error. Or even in thermometer, even in vernier caliper, even in micrometer screw gauge, there may be a small error, and those errors can be minimized or avoided. But least count of the instrument is the error in the measurement of the instrument. Okay, so this is the first part. Then second error is error due to imperfection in the experimental technique. If in the experimental technique there will be imperfection, if there is not proper setting, if there is a defective setting of the experiment, then also it will error, and that this is the second type of the error, which is due to the imperfect setting of the instrument or of the experiment. That error will be second type of the error. For example, suppose you want to measure volume, then the beaker should be vertical. When you measure volume, then it should be vertical. If it is not vertical, then there will be error. Means if you see beaker like this, then it will cause error, and that error is the second type of the error, which is due to the imperfect setting, which is due to the imperfect setting of the experimental technique. So, this is the second type of the error. Now there is a third type of the error, which is personal error. Now, personal error is caused due to fault of the person. Also, it is because of the bias of the person or carelessness of the person, that error will cause, and that error is called a personal error. So, the error which is caused due to the person which is doing that experiment, that error is a personal error. If some person or if some student don't know how to take the readings, or if some student will not take the care while taking the reading. If some student is observing some reading and noting some different reading, that will also personal error. So the error which is due to the person is the personal error. So all these three types of the errors are the systematic errors. Now there is a second type of the error, which is the random error. Now even if we take all the precautions, means the apparatus has no error, means the instrument has no error, then the setting of the instrument is perfect, then person is also doing proper, he is taking proper care. Even then, because of the change of the temperature, because of the change of the pressure of the gas, or because of the change of the voltage in the laboratory, means there may be sudden change in the voltage, and it will cause the error in the measurement, and that error is called the random error. Means म्हणजे समजा आपण सर्व काळजी घेतली, म्हणजे पर्सन पण एकदम एक्सपर्ट आहे, त्याने सर्व एकदम ॲक्युरेट रिडिंग घेणारा आहे, त्याला सर्व एक्सपेरिमेंटल सेटिंग पण त्याचं एकदम परफेक्ट आहे, नंतर कोणत्याही इन्स्ट्रुमेंटमध्ये एरर नाही आहे, तरीसुद्धा जर समजा टेम्परेचरमध्ये चेंज झाला ॲटमॉस्फेरिक टेम्परेचरमध्ये, किंवा गॅसचं जे रिडिंग असेल त्याचं प्रेशरमध्ये काही चेंजेस झाले, किंवा लॅबमधले जे व्होल्टेजेस आहेत त्याच्यामुळे जर चेंजेस होत असतील, तर तिथं एरर येतात, आणि त्या ज्या एरर असतील त्या रॅन्डम एरर असेल. सो दिस इज ऑल अबाउट टुडेज टॉपिक, एरर्स इन मेजरमेंट अँड द लिमिटेशन्स ऑफ द डायमेन्शन्स. सो डू स्टडी ॲट होम. सर्व जे प्रश्न मी कॉमेंट बॉक्समध्ये दिलेले असतील त्यांचे तुम्ही उत्तरं लिहा, घरी अभ्यास करा, आज इथेच थांबूया आपण आणि